Are you ready for a candid conversation with industry leaders? Are you ready to explore the latest trends and technologies impacting modern manufacturers? Are you ready for Chris Lou Key in the Creators Lounge?
Please welcome to the Creators Lounge, Matt Draper.
Hey, in the manufacturing world, we talk about why it's so important to keeping our economy strong, why it's so important to bring the next generation into manufacturing. But one thing we also need to talk about is why having a strong industrial base is critical to the protection of our country, which is why I'm excited to have Matt Draper from the Department of Defense here to talk about arguably one of the most important discussions that we're going to have here at IMTS, unlocking defense supply chain opportunities and funding to modernize U.S. manufacturing, U.S. production. So how in the world, Matt, did you find yourself in this type of role with this incredible civic responsibility to our country?
I appreciate it. It's really a pleasure to be here. I've spent my career working up the supply chain. I've spent my time in Scary Gary on the tinning lines, not too far from here in Chicago. I went to school at Northwestern, not very far from here. And I had the opportunity to work at Scott Forge, which is also very close here, great forging company here in the state of Illinois. And then I went off and worked for General Dynamics Electric Boat, which is the prime designer and manufacturer of our nuclear submarines, the Virginia and Columbia class nuclear submarines, and then made the move over to the government. So I've had the privilege of being able to work in all areas of manufacturing in my product. So I'm principally a metallurgist, so I make steel, and I like big complicated things, big castings, big forgings, like this piece that's sitting over here.
No kidding, that is no joke. Like, how did steel become your passion? Because just chatting with you before this conversation, learning a little bit about you in my research, like, we need more people excited about creating stuff like you are. Like, can you tell us how you got in, like, how that became your passion a little bit more?
Oh, honestly, it's really my dad.
Okay.
My father was in Vietnam, and he came back, and he learned a trade. Right? In his case, he started out as HVAC, but I spent my time as a kid working for my dad, crawling around in attics, doing different things. And my grandfather was also in World War II, and he came back, and he ended up being an antique hardware restoration guy. So I spent a lot of time working around trying to make things. Mm-hmm. Right? But I was always more interested in the design of the products. I always kind of had that engineering spin to it. And when I was in high school, I lived in Florida, so I was very interested in NASA. You could see the space shuttle launch from my backyard. So that was always a neat thing to do. And that got me very engaged in engineering. I thought I was going to go work for NASA, but when I came up to Northwestern here, I was introduced to a professor, Professor Olson, who works on things for the Office of Naval Research. And I learned that the Navy is one of the most challenging environments that you can possibly work within. It's way more challenging to put something very deep below the surface of the ocean than it is to go up in space. And I like working on challenging problems, so I was stuck ever since working on Navy-related problems.
Well, not only is putting a submarine deep below the ocean a challenging problem, but let's paint the picture of why the U.S. is facing, let's say, its own challenging problem right now. Some of the supply chain issues that have been bubbling up for decades, really. Can you give us a bit of background on that?
So I'll give you a little bit of a history lesson here. So most capital-intensive industries, like casting, forging, metal manufacture, they go through a 30-year reinvestment cycle. Mm-hmm. And this goes all the way back to the Industrial Revolution. Right? The last time we should have made that major capital investment in this country was in the late 90s, early 2000s. But by that time, the bankers had took over. We didn't make the investment that we should have here in the United States. Instead, we went to emerging markets, or the rebuilding of markets that had fallen apart. So where did all the money go? It went to the People's Republic of China. We built with our money, our capital, built their industrial base. It also went to Russia, because the Soviet Union had, of course, collapsed after the end of the Cold War. So we literally built our adversary's supply chain while we did not make investments in our own country. So there are huge consequences of this. At the end of the Cold War in 1991, for what I started working on in the Navy, for HY steel, that's the steel that goes in the pressure hull of a submarine. Right? We had 55 suppliers that manufactured the plate castings and forgings for that. Today, we have 13. So we've had a dramatic reduction in the number of suppliers that we have available, but we are starting to increase that production. So in the decade of the 90s, we had the peace dividend. The Cold War was over. We built 3 submarines in the entire decade of the 90s. Next year, we're supposed to deliver 3 submarines in a single year. And those submarines are far more technically complicated. They're larger in terms of tonnages than some of the things that we produced historically. So we have to produce at the same levels that we had during the Cold War to deter the potential of a future major conflict with literally a fifth of the supply chain that we used to have.
And I think that paints a perfect picture of the problem, quite frankly, how extreme the problem is. And remind me, we were supposed to build like 30 submarines during the 90s, correct? Am I making that up? It was
No, you're not making it up.
Okay.
So before the Cold War ended, we were looking at building 30 Seawolf-class submarines, and the Berlin Wall fell, and that program was just canceled. So one of the other things that occurred historically here is people were building up for massive manufacture. And I tend to talk about the Navy and the submarines, but this is across the defense era.
Sure.
Right? They were building up for massive manufacture, so they may have spent literally hundreds of millions of dollars capitalizing their industry, and then the program was canceled, completely canceled in the State of the Union address. They eventually were able to lobby back to build 3 of those boats. But multiple companies went out of business because they lost all the capital investment. And those that stayed in the business, some of them just don't want to work with defense anymore. They still have that bad memory of what occurred at the end of the Cold War. And you have the quote-unquote Last Supper that also occurred, where we used to have a lot of defense contractors, and now we've constricted down to just a number you can count on your fingers. And that occurred at the same time. So we've got a lot of dominoes that are occurring here that have set ourselves up in a very challenging scenario to make sure that we defend the country, the warfighter, and deter any future major conflict.
Yeah. Well, I'm interested to learn, what are we, now that we know what the big challenge in front of us in, we have a lot to build with a much smaller supply chain. What are we doing to get it right? I believe Executive Action 14017 has something to do with it. Can you paint a little bit of a picture about that?
So President Biden, in his first 100 days, issued EO 14017 on defense critical supply chains. And out of that, 5 areas of the supply chain were identified. And those are batteries, microelectronics, kinetics, upstream critical materials, things like rare earth elements, and castings and forgings, metals manufactured. And out of the subsequent budgeting cycles in PB 23 and 24, the Pentagon resourced funds against that over 5 years, around $5 billion order of magnitude, to invest across those various different industries to try to bring back the arsenal of democracy, if you will, what it's going to take to make sure that we can build things and, again, deter a conflict. That's really what we're aiming to do, is have that deterrence. And for that, we are investing in everything from workforce development, like the program I think we'll talk about in a little bit here on my shirt, the METAL program, to direct investments in suppliers to try to alleviate existing choke points within that fifth of the suppliers that remain, because now we have to increase the throughput in each of those, to technology development, where we are working to take the human being out of the dark, dirty, dull, dangerous type operations. And we're doing that for numerous reasons. One, there's some safety and health type perspectives to it, but honestly, more fundamentally, it's a workforce challenge. We have a population problem in this country. Right? Our birth rate is nowhere near what it was. It's currently under the sustainable limit, and the only reason that we're still growing as a country is due to immigration. Right? In that type of a situation, you're not going to have a family member who's going to be a welder and a machinist and working on grinding a casting, right? Everyone wants their son or daughter to do the best, right? If you're only going to have one or two kids, it's a very different situation than we may have had a generation ago. So we have to take these old jobs, like burn an arc on a casting, which is an operation where you have to wear a full body suit, a full respirator, and you get dirty. We need to take the human being out of that. And we need to automate that process wherever possible. And that takes the human being out of it, but it also makes it a cool, higher paying job.
Right. Well, we're going to talk a little bit about how you're doing that. You just rattled off a few programs, a few of the challenges that we want to go into right after our sponsor break. We'll be right back. All right, we are back with part two. We're joined by Matt Draper with the Department of Defense. So we were just going through the challenges. We were going through a bit of the I'd say, proactive measures we're starting to take, but they do still feel a little reactive. You addressed 5 critical areas of the supply chain, but let's go into some of the specific programs. Let's talk about the one on your shirt right out of the gate. Tell us a little bit about that.
This is one I'm very, very passionate about. It's an angle of our workforce development program. So we need to get kids excited about manufacturing.
Yeah.
We have lots of data at this point that shows us that if we don't expose a student to STEM, by the time they're in 6th grade, and if they're not engaged by that, not only do we lose them in STEM, and engineering type careers, but we also lose them in manufacturing careers. So we have a multi-tiered program here. This is the metal program. We also have ACE, which is America's Cutting Edge. This is for manufacture things like castings and forgings. On my shirt, America's Cutting Edge is about machining. Right? And in that type of a program, we start at kindergarten. We are trying to expose students to how cool manufacturing is and trying to give them capabilities to make something. So I work in castings and forgings, right? That's hot metal. So how do you introduce a kid to hot metal? Oh, we can make chocolate. Imagine what I can teach a kid using the manufacturing process for a chocolate bar. I can teach them about molds, about how you're trying to heat things up, about controlling that manufacturing process and getting repeatability in the product. So that's what we do at that grade level. Then we take a step up, so more targeting, say, the 18 to 30 population. We have boot camps. So if you have never made anything before in this type of space, in 1 week, we will condense down curriculum. By the end of that week, you will make something. Not the instructor, you are going to make something. And we do that in both the metal program and in the ACE program. So for instance, this piece that I have here on the table, right? This requires some very, very complicated G-code. This is a more complicated example than what we might make in one of the boot camps. But you may walk in never having made a piece before, and at the end, you go home with a widget that you have made yourself. And we found that to be extremely important. Because again, you're trying to get the kid invested in it, but you're also trying to get their parents and their friends interested in it. Yep. So if they can come home and say, I made this, there's a certain amount of personal pride that someone has to being able to do that. And then, of course, on the back end, we have full-scale apprenticeships where we are partnering with industry, in this case, casting and forging companies, and we are finding students, we're finding apprentices and plugging them in and giving them jobs. And at that end, it's about uplifting people.
Yeah.
We are providing them not just a job, but the opportunity to have a career. And we can do that, again, very, very quickly. And this filters into a number of different programs that we have. Like we have ADTM down in Danville, Virginia is another node in our network of workforce development, where in 4 months you intensively learn a trade. Whether that's non-destructive testing, machining, metrology, welding, additive manufacturing, right? Very intensive 4 months, and then you can go and get a job. Right? We're not talking about 2 years or a 4-year education. Quick.
It's a quick,
4
yeah, it's
months.
a very quick turnaround.
Intensive. And that's what the IBAS program that I work for, the Industrial-Based Analysis and Sustainment program, was built on. We were built on changing workforce development. So you can get people quickly in, and we can, again, rebuild that arsenal of democracy. It's not the assets. It's not the physical things. It's the people that matter. And that's our biggest challenge. We have massive challenges, just for numbers, for instance. Just for submarines, just for new construction. This is not sustainment. This is not destroyers, carriers. Right? Over the next 10 years, we have to hire 140,000 people. So over 10,000 people every year for 10 years in a row. That is a massive number of people in skilled trades, in engineering. And again, that's just one program that we have. So that workforce is the foundation of everything that we are doing here. And that's part of what the METAL program is and the rest of our network of workforce development.
This is a great example. A lot of the things you shared were getting kids excited about it when they're young. You're talking about as young as it gets, and then making sure they're into it by 6th grade, like you said. Some of the like 140,000 workers a year is what you said?
Over 10 years, over 10,000
Over 10 years. I mean, that's still a lot.
Well, again, for numbers, for a trade skill, that's about equivalent to the number of people per year the entire state of Florida is going to make available in those type of skilled trades.
Wow. Wow.
So, these are massive numbers.
Well, that's interesting that you say that, because you also talk about, hey, we need tech involved so we can take people out of some of these dangerous scenarios. So tell us a bit about that, because if we still need all of these people, what are they doing when you're trying to make the jobs less, you're trying to make the jobs where the people don't have to put themselves in danger, if you will.
Well, we are never going to replace a human being with a robot. We are going to augment the person and make them more powerful. We don't have enough people to begin with. We're not replacing anybody. Everyone is always just going to be improving their own capabilities. So in that space, we have several $100 million that are going towards the automation of trades, labor, and smart manufacturing, where we are working to build cells where you can 3D scan a component and then automatically overlay that against a 3D model, remove away areas that are non-compliant, automatically come on and do an inspection of that component, like an ultrasonic volumetric inspection, and determine where do you have a defect. And then we use the lessons that we have learned recently from additive manufacturing to teach us how to do autonomous welding. Autonomous welding is very similar to additive manufacturing, but in a lot of parts that we have in the field, we have to repair them. You might have to machine away a little corroded layer on a part and then build it back up before you can reinstall it. We can use the fundamentals of additive and the design thought processes of additive to do that repair in an autonomous fashion. So we have 2 very large programs that are going right now towards that, both with Relativity Space and with Siemens, and we will very soon have a proposal call that goes out, and I would encourage everyone, if you are interested in getting involved in this, please go to cornerstone.army.mil and become a member of Cornerstone. That's where we post all of our funding opportunities. There we'll be posting an opportunity for developing solutions for the automation of trades labor. And that can be any small widget to help you with a machining challenge to massive complicated cells like you might see out here on the floor at IMTS. So we're making a very discrete investment in that. That's over a quarter of my portfolio is in that automation of trades labor space. Again, not just because we're trying to increase throughput, not because we're trying just because increasing quality or making better for the human, but because we have a workforce problem.
Right.
We cannot build what we have to unless we advance technology. And if I can, I'll give you that another example there. Look to Japan and South Korea. That's where we are going to have to be in really just a couple years. Right? They had a population problem. Look at the birth rate that you see in South Korea, one of the lowest in the world. Right? They are not replacing people. That has fundamental challenges, but they were able to solve them, and they've built a tremendous economy around things like shipbuilding and steel production because they bought into automation and smart manufacturing. That is our future. We must do it. It is not an option.
So let's end with a quick call to action here. What is the number one call to action as we wrap this up to keep ourselves on this new right track that we're starting to get on? I didn't want to say get us on the right track because I feel like we're making progress to get there, but
So
what do we need to do to keep the ship?
If you are interested in a career in anything that I have talked about right now, please, right now, go to buildsubmarines.com and make a profile, put in an application. If you are interested in things like you might have a child or you might have a neighbor who is interested in something like this and they just don't understand, you want to go to metalforamerica.org, or you want to go to americascuttingedge.org for the casting and forging side and for the machining side. That can give you an opportunity for a new career, any of those three places. And specifically, if you are interested, again, in working with us on doing technology development, if you're a startup company out there and you think you've got a great option for us, or you're just a small mom and pop business and you want to get involved in defense, all of our opportunities, again, are posted at cornerstone.army.mil. You'll see all of our opportunities, and that crosses workforce development to technology development to direct acquisition, where we're trying to help out an existing supplier. We have tons of opportunities to engage with us. And if you want to talk to me, you can find me on LinkedIn. I am happy to have a conversation with anyone. This needs to be a whole of country effort. We have a massive, massive challenge to deter a potential conflict. Right? So please, come join the family and defend our community.
Matt Draper, everyone, with possibly the best call to action of the week so far, certainly the most impassioned. Matt, it was excellent having you on. Thanks for sharing so much about the situation.
It's a pleasure.
What we're doing about it.
And I have a thing for you if I can. This is called a challenge coin that we have in the Department of Defense. So this is a challenge coin for our medal program.
Let's get
right?
zoom in on that if we
share
can.
That with you here.
We're going to give this a shot. Or at least I'm holding it up. I'm going to guess it doesn't look exactly like the one up there. But I appreciate this. I accept the challenge. Thank you for bringing me in. And
it's a pleasure.
We will be back with more interviews very soon.
Thank you.